In this lesson, I'm going to go ahead and do an example problem with a kinematics equation. So what you're going to have is you're going to have a ball that's being launched up into the air. So you have an object right here, and you're going to be throwing it up into the air. So when you throw it up into the air, you're going to have to give it an initial velocity so that the ball starts to accelerate upwards. So let's say you give it an initial velocity of 20 meters per second. The ball is moving upwards 20 meters per second. Now as it goes up, keep in mind that the ball is fighting against an acceleration of gravity, and the acceleration of gravity, you can write it as a or you can write it as little g, is pointing downwards, so it's negative 9.81 meters per second squared. Whenever you're working with Weber sign, it's good to keep negative 9.81 meters per second squared as 9.81. Keep it as don't round this number. Whenever you're working with in class, in labs, and doing experiments, remember not to round this number. However, if you're just doing word problems, you can go ahead and round this number to 10 meters per second squared. Just to keep the math easy today, we're going to go ahead and round this to negative 10 meters per second squared. Well, what does this mean? This negative 10 meters per second squared means that the ball is going to slow down by 10 meters per second every second. As the ball travels up in the air, it's going to slow down by 10 meters per second every second. That's why it's 10 meters per second squared. So 1 second later, right here, the ball is no longer going to be traveling at 20 meters per second. 1 second later, if it goes from here to here and 1 second has passed, then the ball is traveling at 10 meters per second over here. And then if you give it another second, the ball gets to this point, and you give it another second, then that means that the ball is now traveling at 0 meters per second. Keep in mind, the acceleration of gravity is impacting the ball at all times. It's always there. Gravity is always present. So it went from 20 meters per second to 10 meters per second, from 10 meters per second to 0 meters per second. And then when the ball falls back down, it's going to do the same thing. It's going to start off at 0 meters per second. When it comes down 1 second later, it's going to now increase by 10 meters per second. So it's going to have a negative velocity, because the negative just simply means downwards, as upwards means positive, as positive means upwards. So as the ball comes down, it's going to have a speed of 10 meters per second over here, a velocity of negative 10 meters per second, and then 1 more second later, it's going to have a velocity of negative 20 meters per second, because whatever gravity takes away from you going up, gravity is going to give it right back to you as you come down. Now you can solve this conceptually, or you can solve this by realizing you've been given a lot of variables. You've been given the initial velocity, so we're going to put a check. You know the acceleration is negative 10 or negative 9.81 meters per second squared. If you want to analyze the motion of the ball going up, then right up here you can call that your final velocity. So you can say, look, I also know my final velocity. And so if somebody asks you, give me the time, that's your unknown variable. How long does it take to go from here to this point, from 20 meters per second to 0? You can do it conceptually and say, hey, it takes 2 seconds. Or you can do it using your kinematics equations. You can say, I'm going to use my acceleration equation. Acceleration equation is final velocity minus initial velocity over time. And you can rearrange this for time by multiplying both sides by t. You take your t over here, and then you divide both sides by a. And so now you have an equation that simply looks like this. T is equals to v minus v naught over a. And you can plug in your variables. This is v naught. So for final velocity, you can plug in 0, because that's the final velocity as the ball gets up to the highest point, because we're analyzing the ball as it goes up. And you can plug in 0 in here, and for initial velocity you can plug in 20, so initial velocity is 20, and for acceleration you can plug in negative 10, or if you want to be accurate you can plug in negative 9.81, and basically your time will come out to be 2 seconds, which is correct going up. Now if you want to analyze the ball's motion going up and coming down, you can do this conceptually and say, hey look, if it takes 2 seconds to go up, it's going to take 2 seconds to come down, so that means the total time to go up and come down is 4 seconds. You can do it conceptually, or you can do it using your equations. You can say my final velocity as the ball comes back down right here, when the ball is right here as it comes back down, the final velocity over here is going to be negative 20 meters per second. So you can say, okay, if somebody wants to know the total time going up and coming down, my initial velocity is 20 meters per second. So for initial velocity right here, you're going to plug in 20 meters per second. For final velocity over here, now you're going to plug in negative 20 meters per second. So you're going to have negative 20 minus 20 divided by the acceleration is negative 10, and that'll come out to be 4 seconds. So you can use these kinematics equations to help you in solving these problems, or you can use them conceptually, as long as you understand what acceleration means. Remember, acceleration means a change in velocity with respect to time, so it's meters per second squared. And always ask yourself, what is my initial velocity, what's my final velocity? Whenever you toss a ball up at the highest point, the final velocity will be 0. And at all points, right here, here, at all points, gravity is constantly going to be negative 10 meters per second squared. So if you ever get a trick question and they ask you when is gravity 0, you'll say gravity is always negative 9.8 or negative 10 meters per second squared. The velocity at the highest point becomes 0 because the ball comes to a stop for a brief second, for a brief millisecond, and then the ball starts falling down. And if it's symmetrical, then if it started off with 20, it's going to go up to 10, it's going to go to 0, then finally it's going to come down, and it's going to be negative 10 meters per second squared and negative 20 meters per second. Keep in mind, the negative simply means downwards, just like positive means upwards. So hopefully this quick review on using your kinematics equations was useful to you.